This is a video to explain how to develop piece 3, and it's a little bit confusing, but up to this point we've learned quite a bit about pattern development, and you have enough information to develop this pattern, but it is a little bit different. If you start examining part 3, and if you do like a distance measurement, and I measure across here, that distance is 1. Okay. Well, if I measure perpendicularly across these lines, the distance is 0.7071. Okay. So then you start looking, and if you were just looking at part 3, you could actually think, well, maybe this is a rectangular piece. Okay. It's not. Okay. It is an elliptical piece, and the reason that you're able to tell this is because it meets cleanly with piece 2. Okay, that's really the giveaway here, that it's an elliptical pipe. Piece 2 that you can tell is a 3-piece elbow that we've created before, and of course the ends are circular. Okay, and if I measure across this way, this distance is 1. Okay, and of course the connection here in the front view is 1 as well. Okay, so from that we determine that this piece 3 is elliptical and that the connection is circular, but you probably haven't actually run into anything that verifies that for you. Okay, so what I've done, I've created an inventor, a couple of models I want you to look at. Now this is just I won't go into a proof or anything like this, but this is just a cylinder, okay, that has been cut at a 45-degree angle. Okay, now what I want you to notice is that if I look at it straight from the left side, and let me go back to the front view, this is where the 45-degree angle is. Okay, if I turn it 90 degrees, rotate it 90 degrees to the left, you see this. Okay, this is the outline of a perfect circle. Okay, even though it's not actually a circle, it looks from this view it is a circle, and not only from this view but also from the top. Okay, it's also a perfect circle. So you can just kind of remember that if you have a cylinder sliced at a 45-degree angle, there will be 2 other views at least where this angled surface looks like a 45-degree angle, and I think it is just 2 views. Okay, so from the left side in this case and from the top. Alright, but what we're looking at is an elliptical pipe. Okay, and if I were to just rotate above, this is kind of what the elliptical pipe looks like in your drawing. Okay, this is what it looks like from the top and the front, and you can see the ellipse here. Now what happens if you look at it at a 45-degree angle? Okay, and the best way to do that is click here on Inventor. Okay, that'll rotate it exactly 45 degrees for me, and that is a perfect circle as well. Okay, so when you're doing the development, you have to think in terms of this geometry. Okay, so I'm going to go back to the AutoCAD drawing and go ahead and show you how to do the development. And what you need to do is, before, for circular pipes we were using a circle. Okay, well this is an elliptical pipe, so we need to use an ellipse. Okay, so I'm just going to type ellipse, and I'll just start off here at the corner and go perpendicular across as one of my axes. Okay, and that again, this measurement from magenta line to magenta line is 0.7071. The other measurement was 1. Okay, and what AutoCAD is asking for now is the distance to the other axis. Okay, and actually what I should do before I do that, let me copy this line in the middle to the midpoint. Okay, I copied and snapped to the midpoint here, and the reason I did that, I need something to snap to. So let me type in ellipse again, start off at the corner, perpendicular across, and then the distance to the other axis is the distance from the center of the ellipse to the outside of the ellipse, which is 0.5. Okay, the total distance across the major axis will be 1 in this case, but we only need half of that when we put our dimension in AutoCAD. Okay, so that's what our ellipse looks like here. Now just out of habit from using the wheel before, or the circle with the the equally divided segments, you'll want to use the array command. Well, you can't use the array command here because the array command divides the circle by angles. Okay, in other words, if you put in 12 segments, it divides 360 by 12. Okay, now if you did that with the ellipse, it wouldn't work. Okay, what you need to do is to use the divide command to divide the ellipse. Okay, let me show you the difference between the two. I will start off just like we would with the circle with the array command, and I'm going to make these lines yellow. Okay, and then I'll use the array command. Okay, alright, now it divided it up, true enough. Okay, but now what I want to do is to use the divide command, and I will divide the ellipse into 12 equal segments. Okay, and you can tell by where it places the points that the lines don't cross through. That's why you can't use the array command. Okay, so I'm going to go through and erase these yellow lines, okay, because I can't use most of them. Alright, and from the center point I will draw out as we talked about before, be careful you're snapping to the correct place. Alright, so now that we've done that, we can pretty much do the rest of it like we did with the circular pipe. We can copy, like I'm just going to copy this line here, okay, that magenta line I made earlier, and I'm going to go around to all these nodes and attach a line. Okay, and I'm still dividing this pipe into 12 equal segments. Alright, and I will go ahead and change my colors here. That's good enough, and let me extend those down to our intersection point here. Alright, and I think I'm going to go ahead and finish up this video and pick up with video 2. This one's getting a bit long, and we'll pick up with video 2.